Hi guys, a big up to everyone. Welcome to our channel of Sciences and Mathematics. I'm Ernest. Today we're going to look at one of the concepts which is very interesting, and that is the concept of production of energy, especially that is taking place in the sun. Now, have you ever wondered why the sun continues to produce a large amount of energy that of course entails the heat and the light that we see, which of course we find in some of our applications like the solar energy that we are using in our homes. Now, this specific concept of trying to produce energy, of course, lies under the two specific concepts that we're going to look at shortly. And that entails the concept of nuclear fission and nuclear fusion. Now, these two concepts basically stems from the fact that, as we talked in our introductory topic on the constituent of an atom, we talked about the subatomic particles. And we're going to see shortly how the energy that is involved in this interaction of subatomic particles result in the, of course, these two processes that we call nuclear fission and fusion. So basically, before we look at that, there's a very fundamental concept that I want us to look at in this specific video, and that is the concept of binding energy, which is going to act as a stepping stone for us, of course, in understanding these two basic processes of nuclear fission and nuclear fusion. So I'd like to request, of course, some of our members who are already subscribing to continue inviting more so that we can form a large community of our members who are discussing these concepts. So without further ado, thank you and welcome. So as I've said, basically today we're going to look at the concept of binding energy. And the binding energy is one of the areas that we need to tackle in order for us to understand the concept of nuclear fission and nuclear fusion. Now we're going to look at this on basically the relationship between these specific two processes and the concept of radioactivity that we have already talked in a number of our videos. Of course, I'm going to put a link of the videos or perhaps those specific topics in our description box. Now, for today, the concept of nuclear fusion and fission is going to assist us understand, of course, and appreciate the fact that they're being applied in our day-to-day life, especially in the production of power that we, of course, already come across, that is known as the nuclear power inside the nuclear power plants. So I've talked about the concept of binding energy. Binding energy. And from the term bind, this one means bringing together. So therefore, whenever we're going to talk about this specific type of energy, we're going to have the concept that this energy entails trying to bring two particular aspects, maybe it can be particles or forms, together. So the energy involved in this particular case can be roughly referred to as the binding energy, but we're going to look at it in a specific context, of course, context in a sense that we have already talked about the concept of subatomic particles that I've already stated. Now, in this case, we're going to look at this topic we are going to look at in depth in atomic physics, and this basically is a topic that is going to entail the interaction of subatomic particles. But we can borrow some concepts from this, especially on the atomic model. And of course, we have discussed some of this in some of our videos. I still encourage our members to go to the description box and check on a range of playlists and try to check out on how we have tried to tackle this concept of atomic models. Now, from this, I can borrow the aspect of one of the atomic models that we have already discussed, that was presented by Niels Bohr and Ernest Rutherford. So this is a Bohr and Rutherford concept that was discussed, or maybe that was presented by the two, that of course consists of one of the description of an atom, whereby the combination of the two came up with an idea, or maybe through experimental data. And during that time, there had already been scientific methods which had been presented, which gave evidence through data that, of course, an atom is made up of particles which are known as the neutrons, and the positively charged protons. Whereas in this specific model, there was this specific area whereby there's electrons orbiting around that specific center. Now, this center was known as the nucleus, and therefore the nucleus consisted of these specific subatomic particles, which are the neutrons and the protons. Therefore, we're going to use this specific model in trying to advance our concept of binding energy. Now, in this case, talking of the concept of energy, we have looked in our topic on quantum mechanics, the relationship between energy and mass. And this is the Einstein energy-mass relationship that we had given or presented in one of our videos, that represents energy as the product of the square of the speed of light times the mass of that specific object. So in that case, of course, we're going to look at this specific relationship here insofar as the binding energy is concerned. But I'm going to give a slight table of the relationship of the mass of these specific subatomic particles so that we can be able to see, or maybe try to use this, exploit these characteristics of these subatomic particles in trying to advance our basic understanding of binding energy. So in that case, I'm going to draw that specific table so that we can be able to use it. Now, from this specific table that I've given, I've tried to show the relationship between the subatomic particles insofar as the charge and the mass is concerned. Now we can see that the difference between the constituents of the nucleus and the electrons insofar as mass is concerned is going to be displayed in this case. So we can see that the protons are positively charged subatomic particles that consist of a mass of so this one proton, this is 1.673 times 10 negative 27 kilograms. And basically this mass is relatively, compared to this one, almost the same, only with a slight difference of this specific decimal point for 5 and 3. Now the difference between the two and the electron, if we try to consider this order of magnitude for the 27 and negative 31, is almost 0.001. So basically, this implies that the electrons are much lighter compared to the two specific subatomic particles for protons and neutrons, in a sense that if we were able to allocate this specific mass for the protons as 1, then for the neutrons it will still be 1, and therefore for the electrons we can give it in that order of magnitude as such. So in this case, we can see that the electron is much lighter as compared to the two, but in a sense that due to the concept that they possess mass, we are going to see that they are going to display some of the properties that we have already encountered in classical physics, that we have studied about the concept of momentum, etc. So from the concept of Einstein's energy-mass relationship that I've written as this and expounded on the two particular aspects and what it implies, therefore we can be able to find a relationship of these specific subatomic particles using this mass energy. Now for binding energy, we know that for particles that consist charge which are trying to interact, we're going to use the concept of Coulomb's law of attraction, which basically describes the strength of electrostatic forces between two charged particles. Now we said that in Coulomb's law of description of these specific charges, we're going to see that if we have like charges, which basically means either positive or negative, then we're going to experience what we call a repulsion. And if we have positive, negative, and negative, positive, which are opposite charges, then therefore we're going to experience attraction. Now in this case, we have already given a model of the Rutherford Niels Bohr's model of the atom, which basically we say that in the nucleus there are particles which are the neutrons and the protons, where the electron of course orbit around that specific nucleus. Now in this sense, if we try to look at this in this way, basically elements, unless it is hydrogen, consist of more than one proton, and if there is a proton that exists in this specific nucleus, from the Coulomb's law of attraction, we have said that if it's a positive, then therefore there's going to be repulsion or repulsive forces which are experienced in this particular nucleus. We're also going to see that the attraction of these negative charges by the protons from the nucleus. So the electrons are going to experience attraction from this specific sense. Now, therefore, if there is an interplay of forces which are taking place around the atom, then we experience that there has to be some kind of equilibrium that is maintained for these specific forces to ensure that the structure of the atom basically is maintained. Now, if there is an instability in this specific kind of a scenario that I've described, then we're going to experience, or maybe there's an imbalance in the forces, then we're going to experience what we call instability. So if there's an imbalance in these forces of attraction and repulsion that we have talked about, then we're going to experience an instability, and therefore we can be able to refer to atoms if, with regard to those specific forces, the balance of those specific forces as either stable or unstable. Therefore, whenever I'm going to mention the term stable atom and unstable, it's going to refer to the forces of attraction that we are experiencing here. And therefore, if we talked about the concept of mass, which has a relationship with energy, and this particular electron is trying to orbit around. So there's a relationship between mass, this mass-energy relationship, and the stability of an atom that basically is going to assist us define what we call binding energy. So from this, we can be able to move to another step that is going to describe the relationship between these specific energies that are found inside the atom. So if the nucleus is made up of the protons and the neutrons, therefore if we know the specific masses and the masses of the protons and neutrons respectively, we can find the mass of the nucleus by adding this specific number of protons and the neutrons that are present in that specific mass. Now, basically that one will be referred to as mass of the nucleus, and this total mass of a nucleus is basically, if we find a relationship between the total number of protons, and then we find the amount of mass for protons, and then we find the total number of neutrons, and we find the total mass for the neutrons of a specific atom, then we're going to find a relationship between the total mass of the nucleus and the total mass of the individual protons and neutrons, and try to compare the two. Now, in some instances, you'll find that there's a difference whereby the mass of the nucleus is basically around maybe 1% of, or maybe there's a deviation in mass whereby the two are not exactly the same, whereby you'll find that there's a slight difference of between maybe 0.8 to 1%, whereby you'll find that the mass of the specific individual atoms put together is slightly, of course, higher than the mass of the nucleus. And in this case, this is going to result in a massive difference. So this particular difference, we're going to refer to it, or it implies what we call the mass defect. So in any case, we talk about the mass defect is the difference between, let me call this one, the result of this one x, and the mass of the nucleus as y. So y minus x is what we refer to as a mass defect if it's not zero. So in this case, we're going to use this concept of a mass defect to try and figure out what binding energy is. So the mass defect that I've said, of course, results from the concept of formation of this specific nucleus. Now, in a sense, we have said that these specific particles do exist together, and there's an equilibrium between the attraction of the nucleus and the electrons, negatively charged electron that is orbiting around to maintain what we call atomic stability. Now, in this case, during the joining together of this nucleus, we're going to have a formation or maybe accompaniment of energy. And in one of our videos that we have talked about the concept of enthalpy, we have said that there is energy that is involved in the formation or joining together of two particles that we call the binding together of two particles. And whenever we're going to have So that is bond formation. And then when we are having what we call a bond breaking, so the concept of bond breaking and formation that entails the release or absorption of energy is basically analogous to this kind of discussion that we're going to have here. So in this sense, we're going to see that there's energy that is involved during the formation of this particular nucleus by joining together the protons and the neutrons. This specific energy is what we refer to as the binding energy. And we're going to see that this specific binding energy is what determines the stability of an individual atom. So therefore, this specific binding energy, as from the case of the enthalpy that we had discussed about the concept of finding energy, the enthalpy using the bond breaking or bond, formation, that we talked about the bond dissociation energies. So in this case, if there's a formation, so in that particular respect, if there's a formation of the nucleus by combination of the protons and the neutrons, the energy that is involved, we have called it binding energy. Now, this is the energy that determines the stability of the nucleus that is going to give us, or maybe result in the formation of either the nucleus tearing apart, or maybe two unstable nucleus trying to fuse together to form a stable compound. Now, in this case, this energy can be quantified, and we can be able to see that this particular energy can be exploited in two scenarios that I talked about during the process of fusion and fission. Especially in the first one, we're going to see that this one is exploited in the nuclear power plant that we already have in some of our energy systems, which assist us in producing, of course, clean energy. So the concept of binding energy is very important, and we're going to see that different atoms can display different properties insofar as binding energy is concerned. And the relationship between these binding energies and the stability of an atom, of course, that is what gives birth to the concept of nuclear fission and nuclear fusion. Now, in this case, we're going to discuss the two processes in an exclusive way, because I've already I felt that it was important for us to tackle this specific topic, because basically from that is how we're going to understand how these specific two processes take place and be able to comprehend on how we can be able, or maybe how they have been exploited in order to assist us find solutions to challenges that are existing in our problem, our various environment, like the concept of power that I've talked about. So in this case, I hope that this is going to assist us in finding out how we can be able to describe different aspects of a nuclear fission and fission. And I invite you to check out on our videos that we're going to do after this, of course. So that is it for now. Thank you. Bye. God bless.